Hi, welcome back to the Math Resource Showcase. I'm Amber Soto, and today we're going to go over the solution for Gabriel's problem, which is a problem that we shared yesterday from the Enrich website. Normally at this point, I'd go back to their website to show you where we got the problem, but I created this little graphic organizer for myself so I could show you solve it. So I wanted to make sure to emphasize that it came from Enrich with no E, so nrich.maths.org. Don't forget that S on the end of math, maths.org. Okay, so I wanted to first go over the problem really quickly. So it says Gabriel wrote the numbers 1 through 9 in a 3x3 grid. He then multiplied together all the problems in each row and wrote the resulting product next to that row. He also multiplied the numbers in each column together and wrote the product under that column. So all the numbers 1 through 9 that he put in this 3x3 grid, if you multiply it across the row, the number at the end is the answer that they get, the product. If you multiply it down the column, the number at the bottom is the product that they get. So if we're talking about products and multiplication here, we're really talking about factors. If we know that there are certain factors of each of these numbers, then we know that these numbers that multiply to be that number have to be factors. We can't put, for example, a 9 here and multiply it by other things to get 60 because 9 is not a factor of 60. So where I decided to start with this, and there's a lot of starting points, trust me, so if you did this a different way and got the same answer, it's still fine. But I decided to figure out what the factors for each number were. So for example, for 24, I know 1 is a factor of 24. 1 times 24 is 24. I know 2 is a factor of 24. 2 times 12 is 24. I know 3 is a factor of 24. 3 times 8 is 24. I know 4 is a factor of 24. 4 times 6 is 24. Now 5 is not a factor of 24. If you divide 24 by 5, it's not going to come out evenly. But 6 is a factor of 24. 4 times 6 is 24. And then 7 again won't divide evenly, but 8 will. 8 times 3 is 24. And finally, 9 does not go evenly into 24, so it's not a factor. So I did that for each of these numbers. Now I actually have it already done because I don't want to take up a lot of time in going out through all the factors. This is something that once you kind of figure out how to do it, you can figure out the factors as well. But I wanted to step you through my thought processes as I solve this problem. Okay, so once I found out what all the factors were, it became kind of like a logic puzzle in that there were only certain places certain things could be. So let me give you a for example. The number 9. 9 cannot be here. It's not a factor of 60. It can't be here. It's not a factor of 21. It can't be here. It's not a factor of 40. And it can't be here. It's not a factor of 24. So that means 9 has to be here because it's a factor of 378 over here and it's a factor of 288 here. 9 can't be anywhere else on this grid. Okay, so using that same logic, I looked at 21. 21 only has 3 factors listed, 1, 3, and 7. So that means these 3 down the center column have to be 1, 3, and 7 in some order. So I had to think through which one's going to be which. Well, 1 can be either of them, any of them. 3 could be either here or here. It's not a factor here. But if you look in these side categories, 7 is only here. This is the only place 7 can be a factor. So that means 7 has to be here. All right, and then if we go across this way, we know that these 3 numbers have to multiply together to be 378. So all I have to do really is do some maths. I did my calculations on the side here. 378 divided by 9 divided by 7 is 6. So I know 6 has to go here. Okay, so once I've done that, now I can say, all right, I know this, 6 is taken. Can't be 6 here anymore. I know 9 is taken, so this can't be 9. I know 7 is taken, so this can't be 7. I know that 9 and 7 here have both been taken, and 6, so I can take all those 3 out. And then I know 6 here can't be taken. Okay, and the rest I think are still fair game. All right, so then we go to the next level of it. All right, so again, this was supposed to be 7, 1, and 3 in some particular order. Well, 3 can't be divisible into 40. It doesn't work. So that means 3 has to be up here. And that means in the end, 1 has to be here. That makes sense? So now we can take away anywhere we see 3 and anywhere we see 1. It's going to take away from my factor pool because at this point I've used those. Okay, so I take those out. Now look at what happened here. I still had a 2, but I can't use it because these 3 are already filled. So I can take all my factors away from there. Similarly, I can take these ones away because all 3 have been filled in this direction. Okay, so let me take my 6 off of here. Let me take my 3 off of here. Let me take my 1 off of here. All right, and similarly, let me take my 3 and 1 off of here. Okay, so now we got to look at what's left according to what we have. So once again, we can see that there's only a couple different places that things could be. All right, so in this case, we have 2, 4, 5 on the bottom. In this case, we have 2, 4, 8. So you know 5 is going to have to go here and 8 is going to have to go here. Well, you notice there's no 5 here. There's only a 5 here. So 5 can only go in this row and it can only go in this column. So we know this has to be 5. And 6 times 5 is 30. We need to get to 60. Well, that's just doubled. So that means this has to be 2. All right, cool, that's taken care of. Well, now we have 2 times 3 is 6, and we have to get to 24. Well, 6 times 4 is 24. And finally, we can see that 288 divided by 9 and divided by 8 would be 4, so that means the only number we're missing in the end is 8. And we have filled our column. They should all multiply out to be the correct numbers, and we feel good. Now, again, if you went about this a different way, that's fine too, as long as you can justify your answer. There's a lot of ways to come at this problem. Cheyenne from Oklahoma solved it, and she told me she figured out the first row and then figured out everything from there. So she did it the exact opposite of me. So whatever you did, as long as you can justify it, it's still great. All right, that was a really, really cool problem. I enjoyed that. I hope you did too. Well, tomorrow we're going to learn how to make our own tiles. And I hope you enjoy that as well. All right, with that said, I hope you have a beautiful day and happy mathing.